Today, I'm very pleased to say that we have two great speakers. First of all, Danilo Sato from ThoughtWorks. Danilo is the principal consultant at ThoughtWorks and has many thoughts and influence in the realm of architecture and engineering, specifically within machine learning. He is the author of DevOps in Practice, Reliable and Automated Software Delivery, and a member of ThoughtWorks Technology Advisory Board. So we read his content with great interest here at Selden. I'll let him introduce his talk, as I know that it's him you've come here to hear from. And then after Danilo, we have a second speaker. We'll be joined by Sayak, who comes from PyImage Search. His work focuses on deep learning, specifically solving problems within computer vision, and provides support to PyImage Search readers. I recommend PyImage Search, by the way, as a source of invaluable content around deep learning. He's going to be focusing on TensorFlow Hub, again, another area of interest for us at Selden. But I'm going to hand the floor over to Danilo. So Danilo, I'm going to stop my screen share and allow you to take the floor.
Thank you, Lee. Let me see if I'm doing this correctly. Hopefully everyone's able to see my screens. Great, yeah, first of all, thanks Lee, thanks Selden for inviting me to present. I've been meaning to join the meetup a few times before, and I think the virtual opportunity was something that I couldn't deny, so I'm quite glad to be here. And I want to talk today a little bit about CD4ML and in particularly the challenges of testing quality machine learning systems. Before I get there, I have like 2 or 3 slides just about ThoughtWorks. If you don't know who we are, I have to put a little bit here, but I'll fly through it. We are a software consulting company. We say we help our clients become modern digital businesses, but that means a lot of work we do is around custom software development, machine learning, data, UI, product development, and things like that. We've got now more than 7,000 consultants around the world, and we're spread in many, many places. So you might have heard about us where you are. One of the things that we are quite big, and I'm very proud about, is we like to write a lot about the things that we learn with the works that we do with our clients. So lots of books came from ThoughtWorks. Some of these you might have read throughout your career, or otherwise you might know us more from Martin Fowler, who is our chief scientist. And a lot of the early progress around Agile and continuous delivery came from ThoughtWorks. One of the publications that we put out that actually just came out last week is the Technology Radar, and it comes out every quarter. And we compile a lot of the learnings from projects. So this is all based on work that we're actually doing with clients somewhere in the world. And then what technologies, tools, techniques, frameworks we're using. It's a very cool compilation of like the latest thinking that we're seeing in the work that we do with the clients. So I encourage you to take a look at it if you haven't seen it before. And in particular, there's one blip there that I'm quite passionate about, which is the technique around continuous delivery for machine learning. And I'm going to talk a little bit about that today. I assume most people in this audience is familiar with the problem of trying to productionize machine learning systems and why it's harder to do that than traditional software. We like our production systems to be reproducible, to be testable, auditable, and be able to improve them continuously. And machine learning is almost the opposite of that. It can be non-deterministic, hard to test, hard to explain, and hard to improve. And one of the reasons why it's hard and more complex, if you think about like there's lots of sources of change that we have to keep track of during the process. One of those is the data. So the data itself might change over time. So the schemas might change and you get more fields or new fields added to the same data sets. If the schema doesn't change, maybe the sampling of values might change over time. So the patterns that you have in the data today is not reflected in the future. The volume of data might increase over time, so we have to keep track of that. that change. In machine learning systems, we actually have the model as well that we care about. And that also changes over time. So we might try different algorithms or different ways to model the problem. We might get more training data, which means we can evolve the model, improve it over time. We might run different experiments to try different ways of implementing the model. And of course, we've got the code. That's something that we are familiar with in the software world. And the code we already know changes over time because business needs might change, or sometimes we have bugs that we have to fix or configuration changes. So there's lots of sources of change. And if I go back to the seminal book where Jess wrote about where they coined the term continuous delivery, I like this definition because they talk about CD being the ability to get changes of any type into production or in the hands of users safely, quickly, and in a sustainable way. And when they talk about changes of all types, they're talking about feature code or configuration changes, bug fixes. But I think in particular for us, those new sources of change around the data and the model is another type of change that we want to manage through this process and push to production. And the interesting thing, even though this book was written quite a while ago, if we look at the principles that they line up for how to make this process reliable and repeatable, a lot of the principles actually apply to machine learning systems. And this is kind of the practice of CD4ML came from. It's trying to apply the same principles. The implementation might be different, but we want to be able to create a repeatable, reliable process for releasing the software. As much as possible, we want to automate that. We want to think about quality and build that into the process. We want to work in small batches so we get feedback faster. We want to keep things in source control so we can version and go back in time if we need to. And we don't consider something to be done until it's released, which is quite relevant for us in terms of machine learning operationalization. We can come up with a model in a lab environment, but until it's actually in production and serving real customers, then it's not really adding value. So if we want to think about like all the technical components to implement the full CD4ML lifecycle, there's lots and lots of things that we have to talk about. And that's probably too much to cover in the talk today. I actually wrote an article, Lee was mentioning that. I put a link here if you want to look at it. It goes into a little bit more detail about these kind of building blocks. But the focus for today's presentation, I wanted to dive a little bit more into the testing and the quality aspects of CD4ML. If we're thinking about testing in the context of software by itself, you might have seen this idea of, I call it like the classic software test pyramid. If you haven't seen, I put a link here to Martin Fowler. He tends to have lots of articles and posts on his website that have very good kind of short definition for the terms. So it's kind of like the Wikipedia of the software world in a way. If you think about the testing pyramid, so you have different levels of automated tests that you're trying to write to build that quality in. And then the idea why it's shaped like a pyramid is that you want to have lots of unit tests because they run much faster and you get feedback faster about potential issues that you have. And then you still want the tests around the top as well. Like you might want to test strings to the UI or integration tests, which usually will take longer. So speed is a little bit less. And you can also think in terms of the costs. So the maintenance costs and the cost to write those tests, because the scope of the testing is bigger in those higher level tests, they tend to be a little bit more costly. When they fail, it's not immediately obvious what failed. So you have to dive and figure out which part failed. Versus unit tests, they're usually very, very precise. They'll tell you the line of code that went wrong. But then software got more complex. So we started talking about building distributed systems and microservices architectures, and then the internal design inside those services are also layered with multiple components. We have to interact with things over the network and call other services. So in the software world itself, that pyramid started to getting a little bit more elaborate. So you start adding more types of tests that basically you're trying to slice the components that you're trying to test more finely, so you can still test at the right level of abstraction and get the right feedback loop that you want. And also we talk about exploratory testing, for instance, as at the top of the pyramid, because no matter how much automated tests we write or our teams can write, there's always going to be something that there's lots of value in humans trying to use the systems and finding some weird edge cases or different scenarios that we never thought about automating, or it was too hard to automate. So there's an aspect of that as well. So it doesn't mean we can automate everything. There's always going to be some manual effort, but we don't want manual effort being spent on things that we can actually automate with unit tests or something lower down in the pyramid. The other evolution we saw in normal software is that this idea of actually there's an aspect of testing and quality that you can only see in production. So there's lots of these tests we can run before the software is released, but then during the release and also post-release when it's in production, lots of aspects of resilience and stability and reliability is those are quality characteristics of the system. So if it passes all the unit tests, but then when it goes live, it doesn't stay up and the system is down every hour, that's not a very good sense of quality from a user perspective. The external quality is lacking. So there's a whole trend and lots of new types of testing or new types of things that we can look at that started to blur a little bit more into like the monitoring and the observability sides, that we want to be able to inspect the system, how it behaves in production and what kind of insights and we can gather from that to improve the overall quality of the system that we're building. So that's another learning that we can take into machine learning systems. Okay, so if we think about those kind of three types of sources of change, this brief history of the testing automation that I try to summarize covers a lot in the normal code or application code that we're writing. What about the other two? So I'm going to spend the rest of the presentation just talking about some different other types of testing that we can add to our tool belt. And we'll look first at the tests for the data itself. So first of all, when we're operating data, a lot of the like transformation or the feature engineering code that we write, those can actually be unit tested just like normal software code. We can give like a sample input, run a transformation and make sure that the output looks like what we want. But there's other things that we can do on top of that. So one type of test we can look is the data and the feature validation. So does the data that I'm actually seeing adhere to a schema that I expect that data to look like? So this can help us catch issues when either the producer of the data changes the schema or you have unexpected fields. You can pick up those kind of problems. You can test if the feature can be used. So as an example, like maybe there's some features that you don't want your model to use to train things like race or age or things like that. If you don't want to introduce unconscious bias into how the model is being trained. So you could actually write some tests to ensure that some of those features are not used. And there's also the whole evolution of schemas as well. You want to be able to version the schemas and make sure when the schema changes that it's still compatible. So if someone is reading your data using a previous version of the schema, if you made it backwards compatible, they're still going to be able to read using the old schema when they see the new data sets. If we think about the data pipelines as well, we can do kind of an integration tests, make sure the data pipeline, we give a sample input, we run the whole pipeline and make sure that the output looks like what we want. We can actually do other more sophisticated things around when the pipeline is actually running in production. There's lots of tools now that allow us to almost do the observability of the data pipeline and do those on-demand quality checks. So maybe we haven't seen a value during training or in the data sets that we had when we were building the pipeline, but in production, for some reason, we see some weird value pop in. So we could add some of these quality checks to start alerting when we see different things, and we can handle that as well. Because ideally, we don't want to stop the whole pipeline if we see a few weird values. So we want to be able to flag them and be able to look at them and see whether we need to improve the pipeline or we can handle those cases separately. And also things like adherence to privacy controls. So make sure like the right users with the right permissions are only allowed to see what they can see. So you can test the security aspects of the pipeline as well. Next, I'm going to look at a few other tests when we're thinking about the model building itself. Again, there's a unit test at the level, like when you're specifying the model, you're writing the code to actually define how the model looks like. There's a level of testing that we could do there to ensure we're not testing that the library maybe is doing what it's supposed to do, but we're testing that we're using the library as we expect it to use. And when we're looking at the machine learning training pipeline, we can see, for instance, that the training is reproducible. So it's easy to reproduce that. So if you're training on your machine, or then you're training that in another kind of infrastructure, how stable is that training process, and can you reproduce that? And here's where we start seeing a lot of sources of non-determinism that we need to watch out for. So as an instance, if we have random number generator, we can try to manage the seeds that we're using. So it will try to control some of that source of non-determinism. But sometimes it's like the order that the things inside the model get initialized will mean that the output, even if you feed the same input data, you'll end up with a different output value. Those things are a little bit harder to test. So you're not going to be able to test everything and guarantee the full correctness, but there's some level of testing that you could do at this level. And of course, you can always do an integration kind of test, right? You run the full training in a smaller sample data set to make sure that everything hooks together, all the transformations, they feed each other correctly. And there's some model quality simple testing that we can do. So one test that I usually like to do is like, can we compare against like a simple model? So if I just take the average, for instance, as a very ugly benchmark about for a model, does my model perform better than the simple benchmark? So we can do those kind of tests to make sure we're not putting something that's really, really, really bad out. And other things like numerical stability. So like, how does the model behave when we see things that are like, you expect a number, but you get something that's not a number, or some infinity value shows up? Does the model start giving you like wacky results, or is there something that it can handle? So we can look for those kind of cases. So this gives us some other levels of like testing for the other types of changes that we're tracking. But there's also things that we can fill up in between the gaps, so where they overlap with each other. So if you think about the interaction between the model and the data, we can actually evaluate the model against different types of validation data sets to see how the model performs in those different scenarios. We could actually put things like in the deployment pipeline, or what we call like threshold tests. So we could say like, I don't want my error rate to go beyond a certain percentage, or so it could be either a static value, or it might be some more dynamic thing that you want. I always wanted to improve from the previous version, for instance. Or you can look at either from the execution performance perspective, right? Like, is it taking too long time to train, or does it take too much time to infer compared to my previous baseline? We can look at those quality aspects as part of the pipeline as well. And when we're talking about bias and fairness, we can investigate how the model performs against different slices of the data. So instead of looking at the aggregate results, we could see, we can look at data slices from like, is there inherent bias if we only feed this different type of data when it looks like that? But there's also some important slices, maybe that it's a profile that you want your model to perform really well for that kind of slice. You can evaluate against a data set that looks like that. In the other side, we can also do some contract testing. So in this case, I'm thinking the code on the right could be like the application that's going to use your model. And the model is deployed as a separate service, or is a different artifact. So now you have to combine those two to actually get value in production. So traditional contract testing is something that we can use to make sure the contract that the model expects is something that the application is adhering to. Another source of problem potentially is the code that you write to generate features when you're training the model is not the same code that the application is going to use when they're generating the same feature in production. So you want to make sure that the feature generation is actually compatible. Otherwise, you might be feeding a different thing than what you trained the model on. And the other scenario, sometimes maybe you wrote the model in one framework, but then it has to be exported, or you need to regenerate it in a different language, or export as an artifact that gets consumed by the application to use it. And when there's that translation happening, usually you want to test it's still kind of the same model. So if you train against similar data sets, does it give you similar kind of performance behavior? And then always, of course, at the top, we can always do full end-to-end things. So like, how does our full system behaves all the way from the training pipeline and deploying the model and using that in production. From the production monitoring perspective, we want to start looking as well, now that the model is live, how do we track that it's not degrading over time or getting stale? We can monitor for things like the training serving skew in the data. Of course, we can monitor the traditional operational metrics, so things like latency and throughputs and resource usage to see if it's using too much resources, for instance. And ideally, you also want to measure real impact, which is something that we cannot measure when we're training. We can come up with like model evaluation metrics, but in production, let's say if we're building a recommendation system, ideally you want customer to actually buy the recommended product. So that will generate sales or orders. So you can track those actual like business metrics against the different models that you deployed and see how the models are impacting the final metrics that you care about. So just to finalize, we looked at many different types of testing. I like this quote. So Edward Deming was like a management guy. He studied the Toyota production process, which is famous in the manufacturing context for bringing the quality aspect into the process itself versus something that we inspect afterwards. But it's really, really relevant for quality for software as well. And he says inspection does not improve the quality or guarantee the quality. If you're inspecting, it's already too late. The quality, whether it's good or bad, is already built into the product. So that's a good way. Like, it is more complex. There's lots of moving pieces and lots of things that can go wrong when we're building machine learning systems. But I think this principle of building quality into it and trying to come up with all the different ways that we can build that in is really, really important. So I think I have some time for questions. I haven't been tracking the chat, so Lee, if you can help me with the chat, if there was anything coming up. I did compile a list of resources here if people want to read more about it or learn a little bit more about it. There's a few workshops that me and my colleagues at ThoughtWorks we've been running just to talk about this concept and show some different implementations of the full process that you can find on GitHub. There's a few articles we wrote. There's actually this paper by Google that talks about a lot of these types of testing in machine learning systems. They actually did a study of internal Google products, which kind of test each product was using, and they show like the distribution of like how are these types of tests actually being used in real systems. So I quite recommend that as a paper to read if you're interested in this area.
Thanks, Danilo. And yes, whilst everyone is hurriedly scribbling down those URLs, I'm happy to assure you that we're recording this session, and Danilo has kindly agreed to make his slides available. So all attendees will have a capture of Danilo's talk and the reference URLs that he shared with us. So we can make sure that we share those afterwards. Danilo, we have had a few questions. First of all, I'm really impressed with kind of, how you're emphasizing kind of automation within the process. One of the things I'd be interested to know, so Selden has put a lot of work into Alibi and how we monitor models in production monitoring. Mm-hmm. I'm wondering, how do you decide when to retrain the model? Are there certain thresholds that you're looking at?
I think that one depends on the type of model that you're doing. So I'm just going to use some examples from a few clients just to talk about that. For instance, we built fraud detection models for like some finance clients, right? So in that case, there's adversaries trying to break your model or trying to find new ways to break or commit fraud, I guess. In that case, the staleness it's very important because you wanna see how much is aging. Sometimes just the time that is being deployed is already enough to say like this is getting stale. Like you don't even have to track other metrics when you have a lot of those kind of changes happening. For other systems, is not as important, I think, to have this. The feedback cycle is really important, but I feel like one thing that we try to do with that, when we tie into the monitoring side, if you capture like how the actual predictions are being made with real production data and you curate that, that's a really good feedback loop. So you train against the data set, and now you have all this kind of data set coming from production that you can see. If you can label, like this based on the production data that you're seeing, is my model actually, if you start finding cases where like, oh, actually the model didn't behave very well. We had a client where they actually had the application wouldn't just trust the model directly. They had another layer on top that the application would had some rule-based thing that they would say like, well, if it's within these rules, then we'll use the model. Otherwise, the application would take over and use a different kind of prediction. So when we tracked those things, that was a very good metric to give us as well. It's like, oh, actually, the model is not being very useful because it's getting overwritten a lot by the application that's using it. So those are some examples, I think, to help think through that.
Thanks, Danilo. And we've had the same question from Carmine and from SIAC around kind of preferred frameworks, frameworks for recommendation that you recommend or are using. What's your go-to in terms of ThoughtWorks toolkit?
Ooh. That's a good tricky question. A lot of the Python stuff that we do is around like the Python ecosystem. You know, like at least like the unit testing stuff we can do with PyTest and things like that, just standard things. A lot of this testing is not really tool-wise, but it's more how we hook it into the pipeline. So the example being like if you're trying to track those threshold tests, of course, you need a way to define what the threshold is, but that's more about how the deployment pipeline will. So you run the training, you capture the metric, which hopefully is published by the model training process. And then you need to evaluate that against the threshold that's part of the orchestration to decide whether the model gets promoted or not. So that's not really like a framework in terms of writing the tests. That one is more around the orchestration side. So and it really, like if you're doing deep learning with TensorFlow, like there's lots of TensorFlow specific libraries to help you test that. So there's a huge list, I guess. I'm not going to be able to come up with them for the top of my head. But one thing I would say, some of the repos that I shared, the GitHub links, we actually have examples of some of implementation of this. They have real code. So it's not like we have examples for using all the different types of libraries that exist. But my colleagues, the one that's the CD4ML scenarios, what they started trying to do is generate different scenarios, because we used to have the same kind of sample application and model that we used in all the workshops. And they're helping us to build a little bit more variation, solving different types of problems, maybe using different types of machine learning techniques, which would require you to use different tools. So we're kind of building a catalog, but it's not extensive. It's more like a few example references that we can look at.
Mm-hmm. We've had another question around kind of AutoML. And the question is, with more and more AutoML tools and frameworks being used, how do you integrate everything with CD4ML? The example cited here is beta AutoML tables from Google that incorporates feature engineering. How do you and how do you play nicely with AutoML frameworks?
Good question. To be fair, like I haven't done a lot of AutoML with some of the clients I worked with recently, but my understanding, at least, of the AutoML, it will assist you a lot with these things, right? So like the feature engineering, they will maybe recommend some features already just based on feeding the data sets, or when you're training the model, we will do the hyperparameter tuning for you, or you will try maybe different algorithms or different ways to use behind the scenes, and you give you lots of models. For those kind of, when you're implementing the solution like that, the feature engineers, I guess, like there is an aspect of like what the schema that you ended up using, even if the feature was engineered by some AutoML kind of library, you still want to capture that because you want to be able to track that against the production usage of that. For the model itself, then it turns more into like a monitoring kind of thing, right? Because you're not actually testing the AutoML guts, how it actually trains and tries all the different types of model, but you're interested in the outputs that it's giving you, and it's going to give you potentially like lots of versions of the model that you need to track. So it's more like a monitoring, and you're going to be testing more from a higher level. You won't be able to test at the lowest levels because you're not writing that code. You just basically skip that, and then you have to test at the higher level because it's doing a lot of the grunt work behind the scenes for you.
Great, thanks, Danilo. So at Selden, obviously, we build behind decks to accommodate kind of security protocols. But Scott asks the question: And I'm guessing that Scott might work at a bank or a defense institute. He asked the question around specific security frameworks like SOC 3 or ISO. Does your method work well within those frameworks?
I think so. SOC is more like a compliance kind of. I'm not in the finance domain as much, but I assume it's some kind of regulation that you have to comply to, right? In finance. So our answer towards that, and if it's not, let me know later. Yes, one thing we actually like to do, even normal CD, even if it's not for ML, in normal software systems, that's also a consideration that people have, security aspects and the governance of like how do you move things around. So we actually do want to incorporate as much as we can of that process into the flow. It bleeds a little bit out from the testing and quality side of it. It's more around how do you model your governance process into the end-to-end, because what you end up doing usually is you have some manual gates through the promotion process that would require people to either you have to produce some report for auditing purposes or produce some artifacts that someone's going to have to look and then approve. So you can model whatever your regulation needs or your governance process needs in the promotion steps that you're trying to automate all the way to get to production. And there's tools like a lot of the orchestration tools, CD orchestration tools, they have hooks that let you define that how you model that pipeline, the deployment pipeline to implement those controls.
Very good. Danilo, we've got one more. So in complex ML pipelines, how do we identify the scope of change impact to streamline testing?
The scope of change impact to streamline. I'm not sure I understand the question.
So the question hasn't been given a name, so I can't flag who asked the question, unfortunately.
I see.
Perhaps you might want to rephrase the question so we can understand better your intent.
Yeah, I'm not sure what streamline testing means in this context.
Okay, we'll give that person a moment to rephrase their question if they'd like. Question from me, Danilo, is you're becoming or what you're creating here is a bit of a standard kind of for the MLOps stack. How far away do you think we are from a standardization within MLOps? Because the hot phrase, everybody's talking about it. Every other webinar I go to wants to talk about it, and yet the definition is still very different from company to company. What's on the horizon for MLOps?
I think from like full standardization, I think we're a bit far away, but I'm actually quite happy that a lot of people are because that's how we learn, I think, in our field, right? Like some of the continuous delivery initial ideas didn't become mature right away. It's about people testing and like building tools around it. And like a lot of the stuff we've done at that time is a lot of the test automation frameworks that came out of ThoughtWorks and like things like Selenium was because we were trying to solve that problem in a real problem, and then we built a tool, and then it got transitioned and it evolved over time, and then eventually now people know about WebDriver and things like that as more of a standard. Similarly in the infrastructure world, right, like Docker was something that kind of came about, and then Kubernetes. So I think those standards emerge over time, but we need this period of evolution where people are trying out to implement these ideas and maybe have multiple tools and multiple ways of doing that. I actually think that's very healthy for us as an industry to explore, and that's how we learn. Because yeah, we're trying, as you said, we're trying to capture the patterns, and some of this is not stabilized yet to say like, oh no, this is if you have this problem, we'll solve like this. If you have this problem, we'll solve like that. So we're trying to capture all the nuance and capture all the examples and maybe all the trade-offs and all the considerations that we have to think about. But I don't think we're at the stage actually to say like, we know the standard now, we can actually define it and everyone just follows.
Very good. Danilo, thank you on behalf of Selden and our meetup attendees this evening. That was a really useful talk, really good one to kick us off this evening. I'm going to close the Q&A on Danilo's session so that we don't rob too much time from, say, our second speaker of the evening. But thank you very much.
Thank you very much. Yeah.